Okay, the Zoom session should be going. Take a look at the Manatee app, kind of review what we had there. I'm going to bring up that PDF document. Try to show you if I can. If you make sure to right-click and open with Adobe Acrobat for this document, then you'll have the table of contents that's clickable over on the side. If you just double-click on that PDF and let it open with your web browser, it won't give you those capabilities. It'll be a lot harder to navigate and work with. So just right-click and choose Open with whatever version of Adobe Acrobat you have. So our Manatee app that we're working on started at the end of chapter 7 in the PDF document, about page 417. And if you remember with this thing, what we have is a desire to keep track of sightings of manatees. So the first thing that we're going to keep track of is the location. So if we look at our UML document here, for a manatee sighting, we're going to keep track of the location of that sighting, and then we're going to have multiple dates. So if we were in Antarctica or wherever there are manatees, we might have seen some on 4/2 and 4/7 and 4/19. And then a parallel array will be the count. So on 4/2, we might have seen 17 manatees. And so we'll be keeping those arrays in sync. How many did we see on a certain day? Now in our manatee sighting class, what we're going to add today are our methods, our actions. So in our manatee sightings class, we're going to add a method to calculate the average, how many manatees we saw in each sighting, find where we saw the most, how many that most was, what date it was, a few other things there that we'll be calculating. We'll skip and choose and just do some of them. And then in our Manatee app, our driver app, our tester app, the one that has our main method, we created a few data fields to keep track of our manatee sightings and how things are going to be controlled. So let's double check and see where we left off. Our manatee sightings class, if you look at it, remember we used those region statements to control collapsible areas of our code. So if you opened it and a whole bunch of stuff was collapsed, remember you can just use those plus and minus signs to collapse and expand those areas. We created some private class fields to keep track of our manatee sightings. We created some constructors to create instances of a manatee sighting, some properties to allow our data fields to be accessed outside of our class, and then we created a toString method. It was getting a little messy there. We'll double check it today as we use it to output all of the information about all of these manatee sightings for this location. So that's what we have so far in our manatee sightings class. Now our manatee app, let's double check it. Not much right now in that class. We have our line of code to create an instance of a manatee sighting, and we just put it in Argentina. We didn't give it any dates or anything for our test. We just created a basic instance of a manatee sighting. We saw that that worked. We used our toString method to output the information about that manatee sighting, and that's about it. So let's run it and make sure everything's working. We should just see that Argentina come out in a bunch of our headings. Does everything look okay? Is everybody's working all right? And it all checked in. If you didn't get it in TFS, don't worry, we'll get a chance to do that here in a bit. All right, so we're in good shape. We had a good start with our class. Now remember, we can use a class diagram if we want to generate a picture, that UML diagram of our class. I saved mine, my class diagram. If you notice in the Solution Explorer, it's a .cd file for class diagram. If you didn't save it, remember you can right-click on one of your class files and choose View Class Diagram, and Visual Studio will generate that class diagram for you. I added my Manatee app class to my class diagram, so now it shows both of my classes. So in our main, we'd like to be able to create more information for a manatee sighting than just the location. So right now we've got it set where we can create a manatee sighting with a location, but let's do a little bit more. So in our main, let's declare some variables to use throughout our application. Instead of just passing our location in as a literal, like we did in this example, let's declare a location string to hold that information. We're going to need to keep track of how many sightings there were at that location so that we can ask the user about each of those sightings, what day it was and how many manatees they saw. So we'll start out saying, how many sightings were there in Argentina? And when they say 5, then we'll prompt them for those 5 sightings. What was the date? How many did you see? Okay, so that'll be an integer value for us to hold that information. Next thing that we need to keep track of is our own array of strings. And this is going to be where we're going to keep track of the days that a sighting occurred. We're going to limit it to 20, which seems like plenty. Now, of course, if we were using the application as a real-world application, we would probably use a more advanced C# structure that didn't limit us to these 20 entries. But for our learning experience, we're going to be limited to 20. Let's put a comment on that. 20 entry array for dates of sightings. Now we'd also like to keep track of how many manatees they saw for each of those sightings. So again, we're going to have that array in our main, in our tester. Let's name it Manatee CNT for count. And it's going to be an integer array, and we'll limit it to 20 also because this is going to be a parallel array. So of course we want it to be the same size. So it's a parallel array for number of manatees. Now in our application, we're going to use an indicator for our user to ask whether they want us to enter more data or not. And we're going to actually use a char data type. So it'll give us a chance to see something just that we've done before, done just a little teeny bit differently. Since we're going to use a char data type, we're going to use a single quote instead of a double quote. So whenever we're using char, we want our strings to be enclosed in single quotes. Now, some languages, of course, don't care, but with C# and Java, that's kind of our standard. Now, one more thing that we need to declare is going to be our instance variable, our instance of a Manatee sighting. So it's going to be the data type Manatee sighting, our class, and we're going to just name it M, super short name. So this will be an instance of a Manatee sighting. So in our test app last time, we called our Manatee sighting instance Site1. But for this application for our tester, we're just going to use the super short name M for our Manatee sighting. So that sets up our variables. Everything is ready to go. We need to have a loop then to control prompting our user for this information. We're going to do this with a do-while loop. So let's start out with our basic structure. We're going to have the do syntax, and then I just pressed enter. And if you notice, it popped all that in for me. So my loop body is going to go within my curly braces, and my condition is going to go there where my cursor is in my while statement. Our condition is going to be based on that enter more data char variable. We want to know if enter more data is equal to the letter Y. For some reason, my fingers can't do the uppercase and the lowercase. Now, in case they entered a lowercase y, we'll do an or condition. We haven't done a lot of ors, so remember that those pipe characters are the shift backslash, the keystroke right above your enter key. We can say, well, enter more data equal uppercase Y or enter more data equal lowercase y.
Just a char data type. Uppercase and lowercase matter.
So we can still have an uppercase or a lowercase y. So if we look at that ASCII data chart, you'll find both of those different characters on that chart. So it'll still know the difference. What we couldn't do is we wouldn't be able to do the to_upper, right? Because the to_upper function only works with strings. It's a string function. Yes, sir?
Wouldn't we be able to, or wouldn't it be more simple to use like the space character? So that there's only one.
If they want it to be done, press space.
Yeah.
Mm-hmm. Yeah. And you might want to train your users to do something like that if you wanted to be consistent throughout your systems. For sure, you could do any of those kinds of things. Well, that sets up our while loop, so we're pretty well set here. Let's put a comment on our do statement. Will it let me? Come on, quit helping me so much. Try to indent this a little bit. So whenever we're using a do-while loop, remember it's bottom controlled, so it's always going to execute at least one time. Because as our code is executing and we hit that do statement, we will do those things that are in there. And then when we get to the while statement, we'll evaluate to see if we need to repeat that do loop body. So the first thing we're going to do in our do loop is ask the user how many sightings they're going to enter. So let's create a method for that information. I'm going to come down to my closing curly brace for the main, be my end of my main, and create a new method. There, it finally let me zoom out a little bit. Now this new method is going to be named getData, and it's going to return an integer value. So we're going to use it to prompt the user for how many sightings there were. And in our method, of course, we're going to validate that we've got valid numeric data. And we could add other validation if we wanted to, like how many, you know, is a valid range and things like that. So let's go ahead and set up our method with our method header. It's going to be a public method, and because we're going to call it from our main, it has to be static. We're going to return an integer value, and we want our method to be named getData. Now, our getData method is going to use the out parameter. So far, we've mostly used the out parameter when we were using the try parse, right? So we know that the out parameter says whatever variable name comes after this keyword out is going to be something that is output from this thing. So our getData method is going to return an integer value, but it's also going to have an output value that's going to be one of its parameters. So again, a little bit of an opportunity for us to see something a little bit different. This output parameter is going to be a string, and it's actually going to be our location. So we're going to kind of cheat and prompt for a lot of these different things all in one method. Not really cheating, but just a way for us to do it all in a nice condensed format. Now the next thing that we want in our getData method is going to be a string array. And within our method, we're going to call that array dArray. So it's going to have the same name as it does in our main method. We're also going to use the integer array Manatee count. So our getData method is really going to use almost all of the data that we have in our main. We're going to set up a couple of variables, integers, one named I and one named loop CNT for count. We're going to issue this statement to clear the console. Now we haven't done that a lot in our code because again, Hypergrade hates it. We would get all upset and say that Hypergrade was broken. So we've just kind of stayed away from it, but we'll try it in this one. Now we don't have the using static statement, so we'll go ahead and just specify our console class for all of these methods. Now we want to write out our Manatee instance. Oops, I got sidetracked there. I was talking. We don't want to write out our Manatee instance. We want to write out the word location, :space. Then we're going to read in our location. After we read in our location, we can use it to form our next message, our next prompt. And in our next prompt, we'll say how many records for that parameter. And we'll replace that parameter with our location. Now, would you rather use an interpolated string? You don't care today? You don't care? Either one's fine. I like to go back and forth a little bit so you don't think the world has ended if you see one. Now, for how many records we have or how many sightings we have, we could kind of think of it that way. We're going to declare a new string called inValue to read in that number. And then you guys have been fighting with this data validation for that enter scores assignment, I know that's a big deal for that assignment because you have to validate as an integer and you have to validate a range. So you're going to see in this example that that's always something that we have to be concerned about with our logic. So we can handle it in so many different ways. In this example, they're going to use an if statement with their int.tryParse, and they're going to use that input value that they just read in and output to our loop count variable that we declared at the beginning of our method. Now we're going to check in that if statement to see if that tryParse returns false. If it does, we're going to output a message. Console.writeLine. Invalid data entered. So it looks a lot like the one you were working on. And then we're going to tell them that we're going to use 0. So we've seen it both ways. We've seen it where we could use a while statement here and add another read line within our loop here, and we could keep prompting them. In this case, we're taking a different approach and just checking their input once. If it's not valid, we're using 0. So either one's a valid approach, depends on our situation. Now, we're going to take that value that they gave us and use it to control a for loop. We already declared I outside of our for loop, so we don't need that int data type keyword, right? We're going to use that I variable that already exists. We want to run while I is less than our loop count, and we're going to add to I as we loop. So within this loop, we're going to be asking them the dates that they saw a manatee. So it's going to be a little bit involved. We're going to do a write statement first off, asking them for the date. And we're going to suggest this format, month, day, year. If you notice in this example, we're not using the C# date, time, data format. We're using a string. So we're just going to kind of control the way these dates are displayed ourselves. We're not going to get the system date, time, data format involved in it at all. There's an example in your textbook in chapter 7 that talks about exception handling. That's really good. That gets a little bit into the date, time formatting. We will eventually, but it can be a whole big topic of its own. It gives us a lot of capabilities. So we prompted for a date here. That's what this console.write statement is doing and saying, here, I want you to enter a date. We're going to take that array, our date array, and at position I, we're going to add in whatever they typed. So now we've added that new entry to our array. We're going to make sure that they actually typed in a date. And it's kind of an interesting way to do it. We're going to say, hey, looking at position I of that D array, that date array, is it equal to an empty string? If so, we've got a problem. We're going to use the write line statement to say there was no date entered. Unknown recorded for sightings. You can abbreviate if necessary. And if that's the case, let's update that array at position I. And instead of setting it to that empty date that they entered where they just pressed enter, let's set it to the word unknown. That's going to give us a way to enter in all of these dates. For each date, we're going to prompt in how many sightings there were too. But let's test here. After our for loop, let's return the value of I. That's going to be at the end. That's going to be the number of sightings that we had. We could also use that loop count variable, right? Either one should give us that value. So let's see what we have so far. In our main, we have the prompt to ask how many records there are. We're prompting to ask what the location was, and then how many records or sightings for that location. And then we've got all of that going, so let's fix it in our main to run it. Got to find it, hang on. Okay, in my Manatee app, we want to find our main method, and where we were creating our do loop, let's go ahead and create a call to our get data method that we just created. It's going to return an integer to us. Let's save that integer in our variable sighting count. Our method that we created was called get data. You remember the first thing our get data method asked for is a parameter, was an output parameter. We specify the keyword out when we make the call also. We're going to use that location variable. Now our get data method required a few other things to be passed to it. Our date array and our Manatee count array. My loop control variable is never changed inside the loop. I'm getting in this baby blue squiggly line. So let's go ahead and add that statement in, prompting the user to see if they want to enter more, or else we'll go into an infinite loop. Do it. Okay, for some reason they want to do like 4 new lines. We'll do it. We can handle it. Do you want to enter more data? Hyphen. Going to continue that. Within parentheses, our message is going to say, enter Y or N. Question mark, space. Now, after that prompt, we're going to be using the readline command to get that data. We're going to make sure that it's char data. So we're going to use char.tryparse. We can try parse anything. We're going to use our readline statement as our input. And for our output, we're going to use our enter more data variable. I'm going to try to zoom out a little bit so you can see that better. So yell at me which one is better or worse. So crazy. So where I am, we've got our console.write line prompting them if they want more data. Then the if statement that I'm adding right now is going to read in what they enter, try to parse that as a char data type. If it's a valid char, it will put that data into our enter more data variable. If it's not a valid char, it'll throw a false, and we can display an error message. So let's display an error message there. Invalid data entered, hyphen, and I'm going to go again to a new line. Sorry, that thing keeps popping up. And then we want it to say no recorded for your response. Now in this case, our enter more data variable is not really going to contain the value no or n, but it won't contain the value y. So it'll in effect contain a no. So that's just kind of how we're going to handle that. Yes, sir?
Is there already set to all those, so when it was that value?
Whenever we're doing the output statement with the try parse, no, it's going to replace it with some different value. Let's check it in the debugger and see what it makes it. Because with the char data type, I'm not exactly sure what it'll make it. Because with our integer data types, it sets it to 0. So will it set it to a space? I'm not sure. Let's actually set a breakpoint to try running our app. So I want to set our breakpoint right here at our do loop. Had to go down one apparently. Wouldn't do it on the do loop. So I'm in my main. I'm at that do loop right at that open curly brace, and I'm going to start running it. Try to get it side by side here with my console. Got a lot going on. Let me move some stuff around here so we can see it. So right now I'm sitting here at this opening curly brace, so that's why there's nothing on my console screen. Nothing's been displayed yet. So I'm going to click the step into, and I should go to my line of code that calls the get data method. I will step into that line of code to go into my get data method. Now in the get data method, as we get started here, we should be able to mouse over those different parameters, and actually we see that our parameter values are all displayed right here beside everything. So in our get data method, our location string is null. Our D array is a string array of 20. Our Manatee count array is an integer array of 20. So we can see those things going in. Now I'm going to click step into again. It's going to clear my console, which was already clear. And I should see now on my console the message location print out. There it is. And it's ready for me to type something in. So where are we going? I can't spell Galapagos. Ecuador. Is that where there are manatees?
Florida.
Florida. Not working right.
I can't.
Yeah, it's not letting me type. I'm going to go ahead and type because it probably is working. And I'm going to continue by clicking step into. Now I'm going to mouse over my location, and sure enough, I was typing. I have like Ecuador, Florida, yay, Ecuador stuff and everything in there. So it was keeping it. It just wasn't showing it to me. But I'm going to have some sort of value in my location variable for sure. So I'm going to continue stepping into. The next prompt that we should see should be how many records for Ecuador, Florida, yay. There we go. And I'm going to try to type something there like 4, enter. Now if I step into again, in my in value, I didn't get anything. I don't know if that one's going to work.
Mine worked.
Did it work? I got to try again. Mine didn't work.
I entered 230 and it worked.
Now you're going to have to run that loop 230 times.
Oh,
Click stop and you won't have to.
sorry.
I'm kidding you.
Oh, wait. You work? I just
You're-
stop.
You can do either way. Okay, try again. Step into. Right now, my location prompt. Now, I'm going to try to type it in. Florida. Okay, I got something there. Now, my next prompt, how many records for Florida? If I click step into so that that displays, I should be able to click beside it and type a number and press enter. Step into. Did I get something? Yay! So now I should go into my loop. I'm going to expand this so we can see a little better. Step into our for loop. Yes, sir?
This message came up saying edits were made which cannot be compiled. Execution cannot continue until the compile errors are fixed.
Oh, so you have to click stop, your stop button,
Okay.
and then see what it's upset with you about. There's an error somewhere, like maybe a semicolon missing.
Oh, wait. There's a random 2 in the middle.
Oh, and it's probably something got typed in there while you were trying to type on the console screen. So don't forget you can Control Z if that happens, because it definitely can happen. Now we're ready to go into our loop here, and we can look down at the bottom. I've got to expand that a little bit, that area. Don't forget that I can look at the local screen and check everything right now. My Manatee count variable is all set to 0. My D-array variable is all set to a bunch of null strings. My location is Florida. All those great things. I'm going to keep clicking step into, and I should print out my first date prompt. I'm going to type something in, 4/1/2019, and then step into to try to read that. I got something there. 4/1/2019. I'm going to keep going. Should put that into my array. My D array now has that date there in my first value. It went through my for loop very quickly, if you notice, because it read that line. As it read it, it put it into the array right there. So since there was no problem, it just continued on. Now if I step into again, since I said there were multiple sightings, I will be incremented. It will still be less than my loop count. I'll be prompted for another date. I'll enter another date. I'll do 4/15. And I'll step into. I should have a valid date. So my if statement should be bypassed. Should start my for loop again. Now this time, I'm just going to press enter without typing in a date. And then we should see our if statement get executed, saying, oh, there was no date entered. So we're putting unknown into the array at that spot. And there, sure enough, there it is in our date array. We got that word unknown popped in there. So we can do things like that that we can check for then later to know that that's a date that's invalid. Now, I entered quite a few sightings, and all of this looks like it's working okay. So I'm just going to kind of keep clicking step into, letting it get angry with me with my bad date, because I want to get through this loop.
Could you click step over?
Let's try step over. Can I do it? Get to that point. Step into, step into. Now I should be able to step over. No. We can step over certain things, but it's kind of a pain. I'll just keep going. I'm patient like that. Or I could just start over. Let's start over. I will type in a location. And then I'll type in a number of sightings of just one. So that I can have a more controlled test here. And what I want to do is get to this spot where I have the do you want to enter more data. And I just stepped right on past it. So we should be able to step one more and see what that enter more data output. It's a character 49. What is that? Now, if you mouse over your enter more data variable, you should see that 49. And right beside it, it has the number 1. Is that what that looks like? Is that 49, the ASCII value? Yep, 49 is a number 1. So it just sets it apparently to 0 or 1, just a 1 if it was an invalid data. So our char data type got set to a 1 since there was something bad there. So we can use the debugger to analyze things like that, questions that we have. So everything looks great, good going. How are you doing? Anybody got problems? What's the matter? You want to show us? Let's see what you got. Can you share? Are you on your laptop? Okay, what's the matter? Did you extract before you opened? Did you?
Yeah.
So, yeah, it looks good. It all looks like it was extracted okay. That shouldn't be a problem. Are there any more messages? Scroll down. Oh, okay. So just a small one. If you double click on that, does it take you anywhere? What else might you try, you guys? What would be a good thing? Touch fry. The Google. Would that be a good thing to try? What the?
There is assembly info.
Yeah, he should Google that. C#. Assemblyinfo.cs could not be found. Let's see what they say. So it looks like it's something that happens, huh? It says rebuild the project. Rebuild solution.
Should be in his properties folder.
Mm-hmm.
That's what that is.
It says it's auto-generated, so let's try that. Go up to your menus and just leave that open and do build. Do you see your build menu?
That's the debug right there.
Build, rebuild solution. And sometimes you guys might need to do this if you run into another problem, like you keep making changes, but it's like running your old code, because sometimes the development environment may not realize your change was substantial enough to require a build. And normally it does that for us behind the scenes, but you can always go do it manually if there's a problem. Now, did that get rid of your error?
Highlighted it saying that
Does it give you a line? Oh, yeah, line.
No, it's just an actual file that it wants. And is that where you have your project on your D drive?
Yeah.
Let's do clean solution. Yeah, like that. So now if you build, oh, that looks better. You might just actually be able to run now. Looks like that error's gone. Oh, there it is. Well, we'll have to fiddle with it and see what we can do. Try your rebuild.
.NET framework.
How do I check that?
Right click on your properties.
Of your project?
Properties. Set bottom. Like when you right click on the project.
So yeah, go up to where it says C#. There you go.
Configuration properties, I think. Try project dependencies.
Cancel there and go down one to your actual project in Solution Explorer where it says C#. There you go. And let's look at the properties for that one.
Yeah, you're using framework.
Yep, everything looks good.
What's in build?
Someone said it's maybe actually valid reference.
Do I?
It says that you have to close and reopen the project and valid reference.
Try that. Close Visual, restart Visual Studio. I don't know what the invalid reference would be.
It would show them as being missing an exclamation mark.
Use your solution. There you go. The purple.
Try running it now.
So if you just get a reference, it would show you there. Or if you go to Solution Explorer, click on references, it will be
It looks good. Well, we'll have to fix you later. We'll just leave you hanging. Don't know what it is. We'll just leave him. We're like, oh, we're so sorry. Actually, I'll help him. We will get it fixed, but we will make everybody watch. since it's not something that's being beneficial, but it started out as something that was. Remember, you have the power, and if you're at work on your own somewhere, you might not have a lot of different people to ask questions of, so the internet can be a great resource. So don't be afraid of it, because of course we don't want to use it for cheating, but we also want to use it for resources. So our loop, as we get back to our program, our loop looks great. We are prompting for these dates to get the dates of the sighting. So let's add a little bit more to that to ask how many manatees they saw for each of these sightings. So where we're going to add this code, we are in our Manatee app, in our get data method that we've created, and we are within that for loop. So in our for loop right now, we are asking for the date. So after the if statement, let's prompt now for the number of sightings. Number of sightings. And we're going to use that same in value variable to read in that data. And just like before, we're going to do a try parse, only this time an int.try parse on the in value. And if it looks good, we're going to output that value to our Manatee count array here at index position I. Now, remember, if that data is invalid, it's not a valid integer, we're going to end up with a 0 at our Manatee count array at that position. Not because it was already a 0, even though it is already a 0, but because the try parse is going to put a 0 in there since it couldn't parse that integer that it was trying to parse. So if that if statement is true, we had invalid data, and we're going to tell them about it. Invalid data entered. Space hyphen space. 0 recorded for Manatee sightings. And now we have everything all set for our input. So let's try running it. I want to turn off that breakpoint because it's really hard to use the console when we're doing the debugging. So if you guys are finding it awkward, you are right. Let's try again. It's just not as easy as some things in the world, huh? So I'm going to put my location of Florida. How many records do I want? I'll try 3. And I'll do 4/1. 2019, we saw 5. And 4/15, 2019, we saw 10. And 4/20, 2019, 3. So remember, that was for Florida. So now we get prompted, do you want to enter more data? This would be for another location. So if we just press enter and don't type anything in, we know that our if statement, our while loop will end. If we type in anything but a Y character, our while loop will end. Let's try a Y character. We should see our location prompt again. You see manatees in New Jersey? I don't think so, but I'll try. 3/27, 2019, we saw 4 of them. And then we get our back to our enter more data prompt. To say no. Now, finally, after all of our output and input, I have that old code where it's printing out that original Argentina instance of our Manatee sighting. So I need to get rid of that, but we'll fix it up here to finish it. Now, when we look at all of this output here, there's some things that we obviously need to calculate to be able to output these things right. We need a calculation for the average number of sightings, the most sightings, and then I think there were a couple of other things maybe. Not too much. So let's start by calculating our average, and we'll fix up this output here. So if I'm looking at a manatee sighting, like it was in Florida, and it was on April 15th, and then April 27th, and I'm going to calculate the average number of manatees that we're seeing in those sightings. Where do I want this average calculation method to go? Should it go in my tester, in my driver app, or should it go in my manatee sightings class? Manatee sightings, because we're calculating the average number of manatee sightings. So it's related to our manatee sightings class. So that's where we want this new method to go. So let's find our manatee sightings class. And in our manatee sightings class, down at the very bottom, we have our instance methods. And right now, the only method that we have is the toString. So let's add a new one. And this is going to be a method to calculate our average. Now, when we calculate our average, we're going to need to know how many manatees there were on the given days. And one support method that we're going to need is they want us to be able to test for zeros. So let's create that method first. Now, in our design, as we were setting things up and deciding how the application was going to work and creating those UML diagrams, we decided that at some point we're going to need to test for zeros in those arrays, because we know if there were zeros there, then we don't have valid data. So let's start out in our test for zeros method with an integer, and it's going to have a long name, number of true sightings equal 0. Now, you guys saw this working with that scores array that you were working on your homework. If we make the array just 100 entries, then what do we do with all of those empty entries when we're trying to do our average and stuff? Do we count them? We can't just use the average method in the array class, because it's going to count all of those empty entries in our array, or empty to us. So we always have to take those kind of things into consideration. What do we need to do with that? So for our app here, this is how we're going to take it into consideration. We're going to use a for each loop, and we're going to use an integer variable named count to hold each of the entries in our manatee count array. Now, in our for each loop, if that item that we're looking at, our CNT item, is not equal to 0, then we can add it to the number of true sightings. If it is 0, we're not going to add it because it just doesn't count. And that's all we need to do. So now we've got the number of entries in our array that actually don't contain 0. That was one way to handle it, of many, 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 many ways to handle it. Now let's use our calculate average method. We want our calculate average to also be public, but it's going to return a double value. And we'll call it calculate average. We'll go ahead and set up a variable to hold that average. An integer to hold that count of how many valid entries there were. An integer to hold our total. And then we can just use a simple for each loop to loop through our Manatee count array. And for each of those sightings, we'll add that amount to our total. So this for each loop is going to add sighting count to the total. Now that we've got that total, let's call our method to test for zeros to get our count of valid entries. Now that we know exactly how many valid entries we had, we should be able to calculate our average. And then we can return it. Now I've got that blue squiggly. What's it upset about? Possible loss of fraction. What's that mean? Perfect. Perfect. Let's cast it. Is a double. Exactly. So now our calculate average is all set. And we see that, you know, some of these array methods that we can use might not be as helpful as they seem like at the outset because of empty entries and things like that. Now, I want to go, if you've got that in, I'm going to leave that there for a second. Since we've got this set up now, we're going to return to our tester, our main, and let's update our main method to call this calculate average or see where we need to update it. I guess it would be better if we stayed within our class here and just updated our toString. Let's find that. There it is, sure enough. In our toString, we even left a comment that the call to our calculate average method should go here. So let's put it there. We could, of course, call that from our main, but we're not going to do it that way. So right here, we're going to call calculate average, and we're going to take the result and convert it to a string. And we want it to be fixed point with 1 decimal place. And then after that, I want to add a plus sign to continue on building our output string. Now I want to go to the tester. Let's go back to that main and fix it. After the while loop, I don't want it to use my Manatee sighting thing. What I want to do instead is within the loop, after we prompt for input, after we call our get data method, right there, let's create an instance of a Manatee. And if you remember, we created that variable and named it M. So let's use that for our new Manatee sighting. Now our Manatee sighting constructor expects the location of the sighting, the array of dates of the sightings, the count sightings array, and finally, how many sightings altogether were there. After we create that Manatee sighting instance, let's output its data. Console.writeLine, that Manatee sighting. And then I'm going to get rid of my stuff down here for my Site 1 Manatee sighting because I don't need it. It was our original testing code. So just those 2 lines, I'll delete. So we should have a good average. Let's try. I'll put in my location, Florida, 3 records. 4/1/2019, we saw 14 Manatee. I guess I'll do like 5. Okay, so now I'm getting an output that has my location of Florida, which is right. The average number of sightings, 7.0. Does that look right? It looks pretty right for what I had there. We'd want to try testing some invalid data and things to see if we can break it. Yes, sir? Is it working?
I just need to see the bottom part of the last year.
Sure.
I kind of missed that piece, sorry.
No problem. Let's find it. I am in the wrong place.
No, you're in the right place. That's where I.
Is that the right place?
Yeah.
Okay, I'll leave that there then.
Sorry about that.
No, this is one of the biggest ones that we've done or will do. And as you guys get more advanced, it gets that way, you know, where we have some really complicated things so that you see the full picture.
Can you please scroll to the very bottom of the get data part?
Sure.
Thank you. That's where I'm missing. It got kind of skewed.
No problem, right there. Yes, sir.
I'm getting an error, a no reference exception. Object reference not set to an instance of an object is something for each was.
Oh, okay. Can you share? Because that's a good error. Let's see if we can show everybody.
Oh, sorry, check the math and the average you got.
Uh-huh.
Right.
Yay.
So, which last part?
Bottom of the get data.
Yeah.
Sorry about that.
Ah, here it is. This is here, data where it starts.
Yeah.
Oh, okay, I see. Go ahead and stop executing and go up to your Manatee app. And then in your main, You can get rid of those 2 lines of code after the while. Delete those 2, but I don't think that was causing you trouble. Try it again. Yeah, everything looks good. That was it? Okay, good. Yay. All right. Okay, so in our Manatee Sightings class, we have a few more methods that we could create, like what was the month that had the most sightings and the date with the most sightings. There's just a couple of methods, so I'm going to leave that with you with that PDF file so that you don't start shooting me with things up here, and let you do that on your own. Take a look at it, and even though it's kind of difficult to use the console with this application, if you can, try to set it up through the debugger and step through it. This one really is complicated because of all of the different arrays that were being used. We ended up with a date array and a count array in our tester app, where we were allowing users to input data, and we ended up with the date array and a count array in our class, where we were retaining that data for all of the different locations that we've used. So we had it in 2 different places. Questions about it before we put it to sleep? Got it? Take a look at it. Really try to wrap your head around it. Think about all of the things that were going on within this app. In Chapter 7 of your textbook, the PC Pro, the Pro 7 Sharp 1 thing, that one, the big one. If you look at Chapter 7, they have some really good examples. So let's see if we can do this car exception really quick. Car exception. Let's save this project and let's create a new one. Now, with this new project, before we get started, we need to check in everything on this one to TFS, all of these changes. So if you're having trouble with TFS, just minimize this project so that we can get it fixed for you. But if you're not having trouble, you're just going to right-click and choose Check In and push all of those updates to TFS so that you could do the Get Latest Version at home and grab all of the project so that you would have everything there. Now, as we saw with some of the problems that we had, which were great, all of these support files that are part of our project, like the properties and the references and things like that, that kind of behind the scenes things, those all matter. Bless you, sir. That's why when we check in, I like for you to check in at that solution level so you're sure to save all of those different support files that go along with your project and none of those pieces get lost or missing. You don't have to. TFS will let you just check in this Manatee Sightings.cs file. You'll be screwed because you won't have anything else that goes with the project, but it will let you. So it's going to let you check in exactly what you tell it. So always tell it to check in the whole solution and get everything. All right, so if we're checked in then, we're ready to close this one and create a new one. Now, before you create a new one, if you need to, check Team Explorer, make sure you're connected to TFS. It hasn't switched to GitHub on you. Sometimes it'll do it like while you're working. I don't know why. GitHub is really persistent. I'll be glad when TFS just goes completely away and we only have GitHub to worry about, because then we won't have to fight with it all the time. It's getting harder and harder. So now I want to create, again, a new project. And this is just going to be a console app. And I'm going to call it Chapter 7 Car. Let's call it Car Exception. So I want you to have that in your name. And if you've already pressed enter, that's okay. I do have the box checked to add it to source control. So it's going to be automatically added to TFS when I create it. I'm going to pick where I want that to save.
I went back to GitHub. I even checked mark to.
Yeah, we've got to get yours fixed somehow. It is angry. We'll fight with it. Okay, I've got all this code from them, but I'm afraid I'm going to have to unzip it. Hang on. Well, we'll take a look at it while it is unzipping. So in our textbook, what they're talking about with this application that we're going to create is a little car. So we're going to create a class that is kind of the status of our car. So here's our car class, and I'll get these files for us so that we don't have to type it all in. We should just be able to copy them. But we're going to have our car class, and the car class is only going to have one data element, the max speed. How fast can it go? Now, it's going to have a couple of properties, though, because it's going to have an integer property for what its current speed is, and another property for what its pet name is. So notice it's just this textbook does things a little bit differently. We're also going to have a class variable that's a Boolean that describes if the car is dead. We're going to have an instance variable of a radio if the car has a radio. We'll have constructors for our car and a method that lets us crank up the radio. So I think I've got our car class here. I'm going to put it on the chat, maybe. So there is the car class and the program.cs. I'm going to open the program.cs and just copy and paste everything out of it into ours. And then I want to create a new CS file, a new class in my project called car. So I'm going to right click and add. Oops, I need to be on my project. I was on my solution. I'm going to add a class called car.
You didn't get your full using statement.
Yeah, something's not right. I could handle that. Okay. Now let's take a look here. In my car class, let's see, do access my radio class.
Where do you get this code?
This code, if you look in your book, there is a cryptic reference to a GitHub location, but I've also posted it to Canvas. So let me find it in Canvas. I don't remember where I've got it posted.
We're not supposed to be following along, right?
You should be able to just grab that code I put in the chat.
Okay, I joined like just now, so I can.
Oh, okay. Yeah, if you're not in the Zoom already, you won't see the code. So let me know, get in the Zoom, because otherwise you won't see the chat. So here's the program.cs that we need and the car.cs that we need. And then we also need our radio class. These should all be pretty short. So I'm going to put the radio class in the chat. And I'm going to create it myself. Can do it however is working best for you. And yeah, if you had to join late to the Zoom session, let me know so I can send it to you again. Did you just join it? No problem. Okay, so the radio class is super small. You notice they're all actually pretty short. Okay, here's the radio again, and program.cs, and the car. So not too bad. Let's see if we've got everything. This is the radio class. It's really small. All it has is this one method to turn on the radio. And if we turn on the radio, we'll be outputting the message that we're jamming. If the radio is not on, our Boolean is false, we'll output the message that it's a quiet time.
I guess that makes sense.
That's it for our radio. Now let's look at our car class. Our car class looks a lot like the one in the book that we were looking at while it was unzipping. We have our variable to keep track of our maximum speed. And then some interesting properties. They violated those rules, didn't they? Because they don't have private class variables. All of these are just public properties. We can do that if we want. It's not recommended, but we can. Now we have an instance variable that is an instance of a radio, whether it's off or on. All our constructors. Now, what we're really interested in here in this test mode that we're looking at is this accelerate method. Our accelerate method says, first of all, check the Boolean to see if the car is dead. If the car is dead, output, I can't accelerate, the car is dead. But if the car is not dead, check its current speed. Actually, we're going to add to it by this delta variable that was passed into our accelerate method. So we'll take that number and add it to our speed. If our current speed now exceeds our maximum, we blew the car up. So we're going to say the car is dead. We're going to say its current speed is now 0, and we're going to throw an exception. So far in our C# programming experience, we've seen exceptions, we've caused them, right? Some of them have been like, we typed in a non-numeric number and we tried to do just a convert without a try parse. That causes that exception. Or we exceeded the index value of an array. That causes that out of bounds exception. But here we're causing our own exception.
Like on purpose?
Like on purpose.
Oh.
And because in our class we've said, we've blown the engine, we can't go any further. This is a problem. So I'm going to throw an exception to tell whoever is using my class that there's this problem, right? So I can communicate. So in our exception, we're saying our car has overheated. We're also going to add in some information to the exception, a link to help the user find out how to drive their car correctly, and some other information. Okay, so now let's look at our tester. Let's look at our program.cs file. In our program.cs, we're just going to output a couple messages, and then we're going to create an instance of a car. This car is going to be zippy, but its max speed is 20. So yeah, it's not very zippy. We're going to crank up some tunes here, and then we're going to try to accelerate, see if we can get that motor running, right? So we're going to do all of this within a try-catch. Well, what in the world is a try-catch? You saw it last time in that code that I gave you for the assignment, right, for error handling. When we're doing error handling, we handle it by using try-catch logic. So we put all of the code for the thing that we want to do within the try statement. Try to do this. Can you do this? Try to do this. I want you to try to do this. If we can't do it, there's some sort of problem, we run into an exception, we're telling the system, I want to catch that problem. Instead of you just throwing up all over the place and coming up with this terrible runtime error and getting the user all confused, let me catch it. Let me do some things with it, okay? So let's try running our application here now that we have it all set up. Oh, it went pretty quick, didn't it? It just did it all itself. So we started out with our messages, and then we did the creating a car and stepping on it. We turned the radio on. We see our jamming message. Then we started accelerating. We got to the point where we were exceeding our maximum speed, and an error was generated. This is where it ran into our exception. In our catch code, we output all of this information. We said, oh, what's some information about that exception? Whenever an exception occurs, the operating system in Visual Studio gather all sorts of information about that exception. What time of day was it? Was it Windows 10? What version of Windows 10 was it? What program was running? What other kinds of things do we need to keep track of about the system? Maybe what all the memory contents were, what all had happened. So all of that data gets bundled up together in an exception object. And then we can use that exception object to get all of this information back out to find out what went wrong. Well, when we created the exception in this code, we said that the message should say, Zippy has overheated. So we see that then when we print out the exception message. Where are we doing that? Let's look. In our catch code is where we're doing that. In our catch code, we said, oh, some sort of exception has occurred. This catch wants to catch any kind of exception. It's wide open. It says if any exception occurs, I want to catch it. Sometimes we might only want to catch our Zippy exploded exception. But in this case, we want to catch any exception. We don't care if it was a problem in the operating system, problem in Windows, problem in our application. We're going to output all this information. Now, when the exception occurs, that exception object is going to be built by the system. The memory, the code, what all happens. We're saying, give me that exception object, all of that info, and call that exception object E. So now within our method, every time you see the letter E, we're referring to that exception object, all of the data and pieces of information that it contains. What was the message of the error? What was the source of the error? Was there a help link in the error? So we saw we generated some of that information, and some of it we didn't. Now, this is the beginning of all of the information that's in that chapter. It's really quick to read. It's very different than the beginning chapters of your book, because the beginning chapters of your book were not easy to read and they weren't really super helpful. This chapter is really good. It's really easy to read. You'll just flow right through it. If you take these examples, you'll already have pretty much half of the chapter in the code that they give you. So do take a look at this. Exception processing is pretty important. And in the example, they show you not only how to throw your own exception, but how to determine which type of exception you want to catch and how to go a little further with it. So go ahead and check this solution in, again, so that you have it at home. I'll just put in something like this is the Chapter 7 exception handling car, because we can put whatever we want there. Get that checked in. Now I'm sitting here on my Team Explorer. How do I get to that Source Control Explorer? Home. Then what?
Source Control Explorer.
Oh, it's right there. Now for my new car exception app, notice how it's bright because I have the same version on my local machine as I do on TFS. Some of my other projects are not. I don't have the same version. You guys probably want to always get latest version up here at this top level until you start feeling really comfortable with where things are. Sorry for killing